some really, really cool stuff. And we're going to continue that discussion. Sorry about that. We're going to continue that discussion today. Yesterday, I think we were right in the middle of doing some calculator work. And I hope I said something like, you really have to pay attention to whether your angle is in degrees or radius. So we did A and B yesterday. I don't remember what the answers were, you haven't written down, but they were both in degrees. So when we typed them in our calculator, we typed them in degree mode. Now, C is not a degree. C is a radian. If a problem is a degree problem, you will see a degree mark. I don't see one in C. I do not see one in D. I do see one in E, and I do not see one in F. So basically, we already did these two yesterday. The only one left that is a degree problem is E. Agreed? So here we go. My calculator is set in degrees, or at least it was yesterday when you left class. I don't know what you've done since then. Make sure it's in degrees. So go to mode, choose degree, and then we're going to type in sine 129 second angle, which is your apps button. Choose the degree mark. 18 second angle, choose the minute mark. And then 13, what? How do we do the 13 thing?
That's the alpha.
That's alpha plus. And please tell me, we're rounding to the 10,000. Please tell me you got 0.7738.
Am I putting that in the parentheses or am I putting the 10?
You don't need any parentheses. Any parentheses will come up automatically.
Okay. Go.
Okay? Now, everything is going to stay the same when we do a radian problem, except we go to mode and change our calculator into radians. So go to mode, look where my little finger is pointing, that's a very important button, mode, and we're going to change it into radian. So highlight radian. Now, letter C. How do I type in a cosecant? We talked about this yesterday.
1 divided by the opposite of what it is.
So what is it?
Sine.
Yep, 1 divided by sine, because it's a cosecant. 1 divided by sine, 5 pi over 16. So this is what we're going to type into our calculator. Physically type 1 divided by sine, and then 5 second pi divided by 16. Pi is right under your clear button, is your pi. And if you did it right, you got 1.2027. Who got that? Hands up all over. Okay. Drew, raise your hand. Do you not have a calculator? Do you have a calculator? Okay. Dude, what kind of calculator do we have for this class? What is this? This is a phone. This is your phone. Okay? So starting tomorrow, you're going to have to learn one every day because you need a calculator every day. Okay? Anybody else? Who else doesn't have one? Let me yell at you too. This is equal opportunity yelling today. Everybody else else have one? All right. All right, now we've got cosine pi over 9. Well, that's an easy one. I have a cosine button, so I'm just going to press cosine, second pi divided by 9, and hopefully you got 0.9397. That one's easy. And then what about f? Notice, do you see how there's no pi? So when the kids see no pi, sometimes they automatically think, oh, it's a degree. No, it's only a degree if it has a degree. If it doesn't have a degree mark, it's a radian. So we're going to type what for this one? 1 divided by tan 2. That's it. 1 divided by tan 2. Now, did you get a negative number?
Yes.
Do not be alarmed. Half the trigonometric functions are negative. We just haven't discovered many of them yet, but their negatives are common. So we get negatives all the time. So we're not worried about that at all. 4, 5, 7, 7 seem about right? Okay. Good deal. Now remember, we have office hours. So if you're struggling with your calculator, either find a friend or get in here for office hours. We got to be able to type this stuff on our calculator. Because we're going to do some word problems. We're going to need to type it in. Okay, number 5. Now, 5 says no calculator. Okay, so we're not going to use our calculator for number 5. For number 5, our job is to figure out what angle, the sine of what angle is 1/2. Okay, so here's what I want you to do. When you're not given a picture, I can't remember if we talked about this yesterday or not, this is the picture you draw. Okay, so some of the problems yesterday, a picture was given, a triangle was given. If I look down at the bottom of this page, there are triangles given. But if there's no triangle given, then that's the one I want you to draw right there. That's called the standard triangle. The angle in the problem, which is this case, I don't know, it's theta, it's the unknown, is always at the origin. So you always put your angle, whatever's in the problem, which in this case is theta, goes right here at the origin. Now, what do I know about that triangle? I know the sine is 1/2. So what's sine? Opposite over hypotenuse. So here's the angle, opposite over hypotenuse. That should look familiar to you. If that's a 1 and that's a 2, then this is going to be a √3. Now you can do the Pythagorean theorem to get √3, but you ought to have this triangle memorized. This is a question, how big is that angle? What angle is across from the 1 in a 30, 60, 90 triangle? This is a 30, 60, 90. 30. So the answer to the question is 30 degrees. Now, it also says answer in radians. Okay, so how do we change from degrees to radians? So Kamara wants to set up a proportion, say pi is to 180, as something is to 30. I got pi over 6 when I reduced everything, but I did that kind of fast. Is that what you got?
Yes.
Now, there is nothing wrong with that. It will work every single time. Do it if that's what you want to do. It works every time. I don't want to discourage anybody from doing it. But, remember that a whole pi is 180. So if we're talking about 30, what fraction of 180 is 30? A sixth. So a sixth of pi. So you can reason these special angles, the 30s and 60s, you can reason those out without going through the actual math. But if you want to do the math, that's fine. But I have no problem with you going straight to pi over 6. Okay? All right, next. Secant is root 2. Now, all the trigonometric functions are fractions. So I will always turn my whole number, or my number, into a fraction. Say secant is root 2 over 1. So here's my picture. Here's my angle. Now somewhere in that triangle is going to go a root 2 and a 1. What are your thoughts on that? Jake?
So secant isn't God's like a reciprocal one cosine?
It is.
So it's 1 over root 2, and then that's adjacent over hypotenuse. So yeah.
Beautiful.
And then isn't
Beautiful. That's what your brain is thinking. Now, you may or may not write stuff down, but somehow you have to understand root 2 is the hypotenuse and 1 is the adjacent.
Isn't that like a 45 thing too?
This is a special triangle. 1 and root 2, the other side is 1. How big is this angle right here? 45. So in degrees, our answer is 45. Now we need to change that to radians. Somebody said it, it's pi over 4, because 45 is a fourth of 180. But if you don't get that, it's fine. You can always do pi over 180 equals x over 45 and work it out. But with these special angles, they're all going to be simple fractions of pi. All right, try the next one. See if you can draw a picture, label the triangle, and maybe even answer it. See if you can figure out. Remember, that's root 3 over 1. Okay, next there. Everybody there? Oh, no Beatrice. Alex, Jaden, Paige.
That's
Are
pretty.
you Ian?
Yeah.
And Emma, nobody sits by
I
you.
think it's just because I started.
Okay, I heard somebody say it's a 30, 60, 90 triangle. Do you recognize when you see the 1 and the root 3, that's a 30, 60, 90 setup? And what angle is across from the root 3? 60. So your theta is 60 degrees, which is what fraction of 180? Pi over 3. Well, it's 1/3. So yeah, pi over 3.
If we can put 2 root 3 to 1 in our heads, if we know that that's what it is, we have to write it down on our paper like that. Would you like us to put it out?
Here's my deal. That problem is doable in your head. I could do that problem in my head. I would assume you can too. If you don't write anything down though, and you miss it, somehow you screw something up, then I can't give you any points.
Okay.
So my recommendation is you at least write something down, because then if you do mess up, I can have partial credit. Yeah, especially if we use these numbers over and over and over again, it does become, you get to memorize. All right, so then we got cosine equals 1/2. All right. So Amanda, how do you feel about coming up here and doing this problem for us? I can do it. That's what I love to hear. Come on up. Bring a friend if you wish. No, he doesn't get right of refusal. If you want him to come, he'll come.
Yes, you got it.
He's a good friend. He's going to help. Well, you help her when she gets stuck. If she gets stuck. You might just watch, because she might get it figured out. Yep, yep. Very good, Amanda. Thank you. And thank you for helping, friend. What do the rest of you think about that? Jamie, okay? Everybody got it? Okay. Now we need our calculators. Because now we're going to look at triangles that aren't special. The reason you could do these problems without a calculator was because they were all 30, 60, 90, or 45, 45, 90. As soon as we start throwing in 57s, then all bets are off. Now, the triangle is solvable, but you're going to need a calculator to do it. All right, you with me? All right, so here's what I want you to do when you look at this problem. Someone's listening, maybe?
I'm listening.
Good. When I look at the angle they gave me, and you can use whatever angle you want, not 90, you could use this one, but to use this one, you have to figure out what it is, and I know it's easy to do that, but I might as well just use the one they give me. So if that's the angle, which side is this? Opposite, adjacent, or hypotenuse? Opposite. This side is the hypotenuse. So in this particular problem, the sides that are involved are opposite and hypotenuse.
Yep.
Which means I'm going to use which function? Sine. Sine 57 degrees equals 32 over y. You always take the sine of the angle. So it's going to be sine 57, sine theta, sine 57 equals opposite over hypotenuse. So now we'll multiply both sides by y and divide by sine 57. Does the arithmetic make sense to you? Then I go to my calculator, make sure I'm set in degrees. I am not, so I'm going to switch back to degrees. 57 is a degree, so I got to be in degrees. So 32 divided by sine 57, y is 38.16 hundredth. Yep. Easy enough? What's the matter, Robbie?
I got a different number.
Are you in degrees?
What did you get?
How do we know when to like use degrees and use radians?
Okay, now wait a minute.
We're using degrees, right? Okay, I'm just making sure it's like.
No. If you see a degree
I
sign,
don't have to think about
you
it.
don't have to think about it. It's in degrees.
Use the degree sign instead of going like
I think so. I think so. I've really never done that, but I think that would make sense. All right.
But this one's degree. This one's degree. Okay.
Okay. You guys, it is, you have to make yourself remember to switch back and forth between degrees and radians. But the minute I write down 71 degrees, then there's no question in my mind. I'm not confused at all. This is a degree problem. All right, now, looking at the 71, which side is the 18? Opposite. And which side is the x? Adjacent. So opposite and adjacent tells me I'm going to use my tangent. So tan 71 equals 18 over x. So x tan 71 equals 18, and x equals 18 over tan 71. So, Braden, this is another example of when you don't have to go through all of these steps. I should see this written down, because that's, everybody's going to write that down. But then this is what I'm going to type into my calculator. 18 divided by tan, 18 divided by tan 71. 6.20. All right, are you clear on that? Now, what I want to make sure is, does everybody understand why we use tangent on this problem, what we use sine on this problem? Totally depends on which side you have, right? So, here we go. Now we're going to draw our own picture, label everything, write an equation, just like we did here, and then solve it. So, we have a squirrel sitting in the top of a tree. Here's my squirrel in the top of my tree. You are always allowed to assume the tree is standing perpendicular. So trees and buildings, walls, unless you're told otherwise, it's some freaky weird problem, you're going to make it a perpendicular, okay? The tree is 52 feet tall. He is looking, meaning the squirrel, is looking at a nut on the ground. His angle of depression is 23 degrees. Now, I want every beady little eye in this room looking at me right now. This angle right here is nothing. You will never label this angle right here. Do you understand what I'm saying? That is nothing. Technically, the angle of depression is right here. The angle of depression, if I look straight ahead and then look down, that's my angle of depression. But that angle is not even in the triangle. So I'm going to put my angle of depression right here, because these are alternate interior angles. Parallel lines cut by a transversal, these will always match. Now, think about this for a minute. If I am the squirrel looking at the nut, or if I'm the nut looking at the squirrel, the angle is the same. So the angle of depression and the angle of elevation always match. This is looking up, so this is an angle of elevation. When you mark your angles of depression and elevation, I really don't care if you want to mark it up here. I always mark it here. These are always going to be the same. So whether it's elevation or depression, I put it right here. So now I have, this confuses me, we'll get that out of there. So now I have a situation where I know my angle and I know the height of the tree, and I am trying to find the distance from the nut to the base of the tree. That is not the hypotenuse. The hypotenuse is the distance from the nut to the squirrel. That could be a question, but it's not. This is X. All right, pick a function, sine, cosine, or tangent. Tangent. Tan 23 equals 52 over X. There's your equation. Now solve it however it works for you. You get 122.50 feet. Put a unit on it. Word problems, we always want to label. Okay, is everybody clear on why we picked tangent?
No.
Okay, relative to that angle, which side is this? Opposite. Which side is this? Adjacent. So what function uses opposite and adjacent? Right?
Yeah.
All right, a seagull on top of a lighthouse. Here's our seagull on top of the lighthouse. He spots a fish in the water below. The gull is 87 feet above sea level. The gull is 230 feet from the fish. Where does the 230 go? Hypotenuse. You just read the question, it tells you. Here's the gull, here's the fish. They're 230 feet apart. Find the angle of depression from the gull to the fish. So this time I'm going to put my X right there. I just went through a big long rant about how angle of elevation and depression are the same. Or same measurement, I should say. So I'm going to put it right there. Now I'm going to write an equation, sine, cosine, or tangent. Sine. Because relative to that angle, I have opposite and hypotenuse. So sine x equals 87 over 230. Whoa, wait a minute. We're writing that. Special button on our calculator. X is the angle whose sine is 87 over 230. So here's another little special piece of information for you. If you are finding an angle, if that's your job, finding an angle, you're going to use this button, or this button. Those are the buttons that find angles. Don't use these buttons for anything else. If you want an angle, use them. If you're doing something different, don't use them. Those buttons find angles. So I'm using this one because I have a sine problem. So here I go. Second sine, which is right above your sine button. Second sine, 87 divided by 230. 22.23 degrees. Kara, did you get that? Okay, so let's make sure no one's confused. On this problem, I used regular tangent because I knew the angle. I only use these buttons when I am finding the angle. All right, next. How far is an airplane from the airport if he is currently 5,000 feet above the ground and the angle of depression of the airport is 17 degrees? So think about this for a minute. Here's the ground. Here's the airport. airplane is up here somewhere, looking down at the airport. How far is an airplane from the airport? If he is currently 5,000 feet above the ground, and his angle of depression is 17 degrees, how far is the airplane from the airport? There it is. This is called the ground distance. So if it asks for the ground distance, we would be down here, but it wants to know literally how many feet's he gonna fly through each way. Take a look at your situation. Sine, cosine, or tangent. Sine 17 equals 5,000 over x. One 101.52 feet. Is that what you got? We good?
Yes.
All right. Next. What do we have? Find the height of a flagpole. Here's my flagpole, here's my ground. Find the height of the flagpole. If it makes a shadow 13 feet long, when the angle of elevation is 59 degrees. Now where am I putting the 13? The shadow is 13 feet long, so where is that going to be?
Bottom.
On the bottom. Kids, that's where shadows are. They're on the ground, right? So that's 13. Sine, cosine, or tangent? Tangent. So tan 59 equals x over 13. So 13 tan 59 is going to be 21.64 feet.
Are we ever getting cosine for these?
Well, we could, and we'd have to be given adjacent hypotenuse.
Yeah.
I don't know if we just have it yet, I don't know, we certainly could, there's no reason why we couldn't. Tangent and sine are the most common probably, but certainly we can do a cosine. All right, one more, here we go, one more. What is the angle of elevation of a man looking at the top of the building? Here's the man looking at the top of the building. What is the angle of elevation? The building is 48 feet tall, and he is standing 100 feet from the building. So the man is standing 100 feet from the building. Where does the 100 go? Right here. Now, if there were a hawk sitting on the top of the building, and it said, how far is the man from the hawk? Then it would be this, right? So if we want to know how far he is from the building, it's right here. Sine, cosine, or tangent. Tan x equals 48 over 100. Okay, wait a minute. I'm for an angle. So what button am I gonna need? Second tangent. If you are looking for an angle, you've got to be using your they're called the inverse buttons. The second tangent, second sine, whatever. So second tangent, 48 divided by 100. 25.64 degrees. You okay there? Okay. We've covered a lot of ground. These first two sections, a lot of ground. So, we're going to continue on. We're going to move on. But, next time we have class, we're going to do a little review of 4.1 and 4.2. By the way, 4.2 will be due on Monday. And then, right, isn't today Thursday? Yeah. And then, so next time we have class, we'll do a little review, and then the time after that, we're gonna have a quiz over the things that we review. Just a little heads up, okay? But what we're gonna do now is plow through, starting with 4.3. What I think you'll find it very easy, so that's why I'm continuing it, because it's good reinforcement. We are introducing one slightly new idea. Now, let's not get confused by the picture, let's not be confused by anything. Would you agree that somewhere out here in quadrant 3, there's a point, -3, -4? And if I were to make a right triangle up to the x-axis, this side of the triangle would be -3 and this side would be -4. Now, I know you don't like the idea of having sides be negative, but I'm going to leave them negative, okay? Because those negatives are going to be important. So if I were going to plot this point, I would go left 3 and down 4, right? Now, let's look at this angle right here. Now, he is the smaller version of the main angle, but for our purposes, we only need the smaller version. This is called the reference angle. It's a piece of the whole thing. Now, for this angle right here, I'll call him theta. For that angle, I need to find the sine and the cosine and the tangent, and the cosecant and the secant and the cotangent. Now, this is no different than what we did the other day, except every one we did the other day was in quadrant 1. And in quadrant 1, everything was positive. Nothing has changed now, except some of these answers are going to be negative. Because opposite is negative and adjacent is negative for a triangle in quadrant 3. Right? Now, what's missing? Hypotenuse. So I'm going to do my Pythagorean theorem, or maybe you don't even need to do it, because 3, 4, 5 is a triple. 9 plus 16 is 25. You may know that or not. If you don't, do the Pythagorean theorem. Important piece of information. Adjacent can be negative, because that's basically your x number. Opposite can be negative, because that's your y number. Hypotenuse will never be negative. That number will always be positive. So depending where you're sitting, these can be negative, but that cannot ever. Here we go. What's the value of the sine? Opposite over hypotenuse, -4/5. Remember when we were typing in on our calculator and we got a negative answer earlier? It's because the angle was in a different quadrant. And if you're in if you're in quadrant 3, for example, sine is going to be negative and cosine is going to be negative. But what about tangent? It's going to be positive because you put the negative over the negative. Now flip them over just like we did the other day. So cosecant is negative 5/4, negative 5/3, 3/4. As soon as you put your angle in a different quadrant, something will be negative. No big deal. All right, let's look at the next one. Somewhere out there in quadrant 4 is the point 3, -2. So here's my origin. I'm going right 3 and down 2 to get that point. Did everybody agree with that? So now I'm going to do, here's my angle right here. This is my reference angle. It's always the angle of the origin that you look at. So let's find our hypotenuse. Remember, when you square it becomes positive. So 3 squared is 9, -2 squared is 4, root 13. Now I want all those things. So here I go. Keep in mind, this is your angle. So here's opposite and here's adjacent. Also keep in mind that your hypotenuse will be positive no matter what. Always the hypotenuse is positive. So what's the sign? -2 over root 13. Cosine 3 over root 13. Tangent -2/3. I've got some rationalizing to do, but look at those carefully. Are you good with that, Abe?
Why is the triangle, why isn't it like down 2 and then right 3? So it's like right
Like this
down
one,
2?
like here, you're saying, why don't I draw my triangle like this?
Yeah.
Okay, great question. Great question. In trigonometry, we have something called the butterfly bow tie. Every triangle you draw will be part of the butterfly bow tie. So no triangle will ever be drawn to the y-axis. They're always drawn to the x-axis. So this one we were using a lot yesterday, quadrant 1. We used this one a minute ago. This is our current problem. And if I had one in quadrant 2, it would be this. So that's a really good question. You need to ask yourself when you draw the picture, is the picture I drew part of the butterfly? As long as it is, you're all set. And the angle that you're always using for reference is the angle here at the origin. Okay? All right. Now, let me rationalize these, and then I think I'm done with this. Okay, we're gonna do 2 more problems, and then I'll shut up for the day, okay?
This 4.
I know, that's disappointing. This is 4. Please keep babbling. Please keep babbling. All right. So right now, guys, right now, we understand that sines and cosines can be negative. And it depends, and tangents. And it depends totally on the quadrant in which you drew your picture. All right, so here we go. The point P, which in the first problem is 2, -2, is on the terminal side of an angle in standard position, butterfly bow tie. Find the values of the 6 functions of theta. Where is 2, -2? Quadrant 4. So there's my butterfly bow tie, right 2, down 2. Here's my angle. What's my hypotenuse? Root 8, which I'm going to go ahead and write as 2 radical 2. Is that good with everybody? Now remember, your hypotenuse will never be negative. So no matter where you are in the butterfly, your hypotenuse is a positive number. Okay, this is exactly like what we've been doing. Okay, here we go. In terms of this angle right here, this is my angle. Here's opposite, here's adjacent, this is hypotenuse. Here we go. What's our sign? -2 over 2 root 2. I'm going to go ahead and do some canceling right away. So -1 over root 2. Is that all right with everybody?
Yeah.
Now, I'm going to have to deal with that in a second, and I will. You can deal with it now if you want. I'm going to wait. What's my cosine? Same thing, only positive. And what's my tangent? -1. So now my reciprocals are -√2 over 1, +√2 over 1, and -1. Remember, the reciprocal doesn't change the sign, the SIGN, positive and negative. The reciprocal just flips the fraction. So now I'll rationalize. Done. Sounded like a really hard problem when we read it, but it's pretty easy. So how did we start? By plotting the point, figuring out where the point was, and then labeling the sides of our triangle. And then at that point, it was just SOHCAHTOA. Okay, one more. One more. Somebody says yes. Don't worry. I saw the student handle it. One more. Here we go. Where am I going to put this one? This point is -1, 4. So this is going to be quadrant 2. So right over here. -1, +4. Here's your angle. So this is opposite, this is adjacent. I need to figure out my hypotenuse. What's my hypotenuse? Root 17, 16 plus 1. Root 17, always positive. Here we go. Sine 4 over root 17. -1 over root 17. And 4 over -1. Root 17 over 4. Root 17 over 1. And -1/4. Rationalize this one. And this one. 17/4. Oh yeah, you probably can't see it because of the TV, sorry. All right. Okay, so homework 4-2 due on Monday. Next class we'll continue in notes, but first do a quick review of 4-1-4-2. Class after that, we take a quiz. Everybody clear on what's happening. Okie dokie, Smokies. Don't leave, but you can unwind for a minute. Pretty intense.